Hello all, welcome to my channel. I am starting a new video series on Ray, which is an open source distributed computing framework. We will have four videos in this series. Namely, first we will have one for the introduction, then we will have one where we will see how we can integrate or use Ray with other systems. Then we will see how Ray is viewed from an Spark developer's point of view. And then we will also see one more video where we will be discussing different other aspects of Ray. So let's get started with the first part. So first thing first, what is a Ray? So Ray is an open source distributed computing framework that is used to make Python functions work in a parallel distributed sense. So what if you have worked with let's say Spark, then you know that Spark works on distributed data and then runs the same computation on different parts of the data. Ray is Ray follows a different approach where it distributes the or it runs a different part of the code or different codes in an asynchronous and distributed fashion. So it flips it, like instead of making data parallel systems, it makes code parallel systems. So that's what Ray is. And a fun fact is that Ray is the engine which powers one of the most compute intensive workloads. For example, uh, OpenAI model GPT-3, DALI, or ChatGPT itself all are running or all are using Ray for its computation processing and training as well. Ray is heavily used in AWS as well. So recently they published a blog where they had mentioned that they migrated their workloads in exabyte to Ray, which earlier they were processing with Spark. So yeah, Ray is very versatile in that sense. It is very well backed by some of the large tech organizations. Architecturally, Ray has basically array cluster. Basically, will have three components. One is a head node, and other one will be worker nodes. And the head node contains the driver process as well as the worker process. But driver process is where the everything action happens in the head node. Then each of the nodes has relay, which is a scheduler as well as an object store, and then we have a global control store and autoscaler. So these are main components of the head node, and then the worker node, we have worker processes and relay servers. So if you uh, have seen Kubernetes, there is a concept of kubelet which resides on each of the nodes. Something similar is here. So we can think relay as something similar to what kubelet does in Kubernetes. Then we have API server, which allows clients to send job requests. So we have one API server, which again is similar to how Kubernetes does. We have an API server in there as well. The driver is the main program, so it refers to the code that runs ray.init. So um, this is the initialization of the array ecosystem. This executes the top level functions that we have. Let's say if we have a main.py file. So whatever is there in the main that gets executed in here. And then once we have initialized the array and what you called we have the code. Driver will decide where to run that code, and it will also send that code to other workers so that it can be executed in there. Uh, Worker processes are responsible for submitting and executing the tasks. So a worker process is nothing but a Python process which is running, and they can be stateless and can be used to repeatedly execute general tasks that use ray.remote annotation. So ray.remote is an annotation that we use on a function. So if the moment we say that, it will be executed in one of the worker processes. The process can also be executed in stateful actors. So if we have a class that is annotated with ray.remote, then that will be a stateful. But if we have a function which have a ray.remote notation, it will be a stateless. When an actor is initiated, a corresponding worker process is also created, and that actors for that actor's execution. So we can think of this as a distribution of code to see how that code gets executed in one particular worker. RayLib, as I mentioned, is a distributed scheduler. It uses peer-to-peer communication. It also has an object store, which is a distributed object store that runs on a shared memory. So that's what RayLib does. This distributed object storage that is there, it is responsible for storing and transferring large objects. And so they are stored locally, can also be referenced on other nodes. For example, let's say if I have one a worker process has certain data and other worker process wants it. So this distributed object storage behaves as if it is there locally, and then we can get that data. So that this reduces the amount of data shuffle that has to be done. Then there is one more thing called GCS, which is a global control service, which acts as a metadata layer for all the processes. It manages and adds or removes nodes. It broadcasts this information to relets. Then it also broadcasts each node's resource consumption to the whole cluster, manages actor creation and deletion. It has a placement group management. It stores the metadata, and it also provides the runtime environment. So GCS talks to Relet. Uh, so when we create a new Relet or we add a new node, it will get registered via the GCS, and then GCS will broadcast this information that okay, new Relet has been added to all the other relets so that they all know that okay, there is a new worker process as well. Then there is a concept of autoscaler. So based on the usage, the cluster can automatically scale up and scale down. So how it happens is client submits a task to the head node sees this task, and if there are no worker nodes, then it will be in the pending state. The autoscaler sees that, then launches or terminates the worker nodes based on idle or pending state. And once it is done, once it creates the worker nodes, the task gets scheduled. And once it is finished, and if the worker nodes are idle, the autoscaler will remove those items. So that's what the autoscaling does in uh, Ray. Then Ray has a compute model called FAST, which is futures, actors, shared in memory, and task. So futures is nothing but a reference to objects that might not have been created yet. Actors is a remote class instance like objects, and shared in memory is a distributed object store, and tasks are remote functions that get executed. So this actor model is something which is very common in what you call Akka. One of the play or Akka or Play was one of the frameworks which uses actor model. Similar concepts is used in here. Uh, so what happens is that whenever a driver wants sees a function, it will first create an actor, and if that actor needs another actor, it will create another actor, and all those actors will be registered with GCS, and then Raylet will come to know about that resources. And the worker, same goes with the worker process. Driver will execute a task on worker A using actor, and then then will execute the task B on worker 2, and Relay will request the resources. So this is the whole framework of the flow of data that happens in Ray. So again, see, driver creates actor A, then if actor A needs something else, let's say actor B, so it will request, or I mean, so it will create and get registered, then to GCS, then if they needed, there will be another actor, let's say actor B, it also gets registered to GCS, and while GCS registers this, it requests for the relate resources, and that's how it gets all those things. So task is a remote function invocation. So a task can be a stateless or a stateful depending upon how it was created, and it uses object references or futures. Then object is an application value. So these are values that are returned by the task created through array.put objects. And objects are immutable, like once it is created, it is only can be referred, not updated. Then we have an actor. Actor is nothing but a stateful worker process. In this case, is a Python environment which executes the tasks. So actor task must be submitted with a handle or a Python reference to a specific instance of an actor and can be modified the actor's internal state during the execution. So these are few things. One thing to know, task are stateless functions. Actor are stateful worker processes, and objects are immutable values accessible throughout the cluster. And this is how we write in Ray code. So first we import a Ray. We have to install Ray, but it is pretty straightforward. Once we have Ray with our code, we do a Ray initialization. Then we say Ray remote. Let's say this function gets executed on a remote function. Then we call the futures like square.remote for each of those four. We will be invoking this 4 times because we have range 4, and then we get the values. Let's say if we want to have a counter actor, let's say we want to create an actor. So as we mentioned, if we annotate a class with an array remote, so we are defining array counter actor. So it has few values, and then we say in remote we send it, and let's say if we say 10, then we will in submit this calls to the actors, and this calls runs asynchronously but in submission order on the remote actor processes, and it gets executed. And then once we are done, we make a call ray.get to get the all the remote values that we have. If we want to define a task that some value in a metric, so we have some metrics function using numpy's uh, and some method where we declare it as a remote, then we call it, and then we if we want, we get the values of all the sums. And if we want to put a large object in object store, we say array.put, and we put that in object store, and that can be referenced by all the executors or all the what do you call actors running in the cluster. So this is how we create a array job, array function. Then we have logging. It offers full logging capabilities. It's something which is very generic. It's mentioned for all. There are different components of array. So Ray has a one component called Ray core, which defines all the task, actors, objects, placement group, and everything. Then we have Ray data. Ray data is a scalable data processing library for ML workloads. We have Ray train for training, Ray tune for parameter tuning, Ray serve for serving a models inference, and Ray live RLib for reinforcement learning framework. So these are different packages that we can use for different work that we want to achieve. Ray core is the basic building block. It defines task, actors, and objects. Tasks are nothing but a regular Python object functions. Actors are stateful workers, and objects are distributed uh, value that is accessible to all the throughout the cluster. Ray data is a library built for ML tasks. It is a what you call it seamlessly distributes data from megabyte to terabyte scale. It has preprocessor as well. And then we have training, tuning. So these are some of the details like how we can train a job, why, what does training, I mean, array train module does, and things like that. So I'm not going through each of these as of now. It's you can read it on the blog, but majorly you can say from the name itself is very clear that we can run these modules to do specific tasks. For example, ray data is for having data access, ray train is for training. The training functions is usually defined. We can also use CPU and GPUs natively. Ray tune is for hyperparameter tuning. Ray serve is for serving the models, and ray batch predictor is for doing a scalable batch prediction. It is built by Ray Air. So this is a different product altogether. Then the APIs that are present in Ray core has there are six basically. Ray init, so initializes the array. Ray remote is to transform the Python function. Then Ray put to put an object to object store. Ray get to get the uh, response until a function calls are finished, and ray wait is just to wait for the things to happen. So these are three different core APIs which are available. Then we have array dashboard, which says that okay, if we open once we run array cluster, we will see something like this, which will say list what are the jobs that are running, what are serving clusters, what are serve modules, it's like serve endpoints, then clusters, actors, metrics, logs, and everything is displayed in this dashboard. Uh, we can integrate Ray with different systems. For example, we can integrate with Parquet, Aero, Spark, DAS, Modin. We can include Scala and Hugging Face and TensorFlow for training. For tuning, we can integrate it with Optuna, TensorBoard, Dragonfly, MLflow. So there are different integrations which are supported by Ray. Uh, Spark versus Ray. Although we have a different altogether blog which discusses this, but to be on the just to give a summary, Spark operates on a coarse grained while Ray operates on a fine grained module system. Then we have SQL-like abstraction called tables in Spark, where we have actor-based abstractions, which is called agent. Spark is synchronous, Ray runs asynchronously. Spark is functional, Ray is object-oriented. Spark follows data processing and transformation. Ray is more suitable for distributed asynchronous algorithms. Spark is very good for data heavy workloads, while Ray is for compute heavy workloads. Ray is natively built, natively GPU oriented. For example, Spark is CPU. If we want GPU access, we need to have something like NVIDIA Rapids or something, some hardware acceleration software. Ray works out of the box. It also has deep integration with deep learning and AML workloads, and Ray is for unstructured data, while Spark is for semi-structured and structured data. We can combine Spark and Ray. For that, Ray DP is the product that we can use. While installing Ray, we can install pip install u, and then we can module. So if we say Ray, then only core gets installed. If we want core, dashboard, and cluster, we say Ray default. If we want Ray data, train, module, tune, or we can simply say Ray all to install all the applications, all the components of that. We also can run Ray on Kubernetes. So we have a kuberay operator which allows us to launch a Ray cluster on Kubernetes. There we have three main components for a kuberay operator, which is called Ray cluster to create a cluster, Ray job to run a job, and Ray service for inferences and things. So Ray cluster resources describe the desired state, and then the kuberay operator manages the lifecycle and auto scaling and everything as well. For example, how auto scaling works is, so let's say the Kubernetes API server is there. Once we initialize this, declare that we want a array cluster of certain configuration. The API server, there is an operator which will watch the array cluster. If the pods are needed, it will create it. And send the request to the API server. The API server will then uh, see if those resources are there or not, and then it will launch using the auto scaler and then do the cleanup and everything. So this Ray operator is very good way for us to get started with Ray on Kubernetes. Uh, so basically, a Ray cluster is composed of three things: head node, worker node, and optional autoscaler. Ray job is a custom resource that lets us execute a single Ray job. Once it is done, it will delete itself. Once the job is done, it will delete itself. As Ray service, on the other hand, it's something which can keep on running. It can run multiple jobs. So array service manages array cluster, also as a array serve application. So both array service is combination of array cluster plus array serve applications. Fault tolerance in array is achieved through GCS, which is global control service, which is also supported in kuberay, which is a separate component that we can deploy. It uses config map, and then so here we have a config map for the array cluster. Here in this case, we are saying Redis config, and then we are launching a array cluster to use this Redis config. And so this is one way of deploying a uh, cluster on Kubernetes. Integration we have already discussed. This can be deployed on Databricks, can be run with SageMaker, Ray jobs, and other stuff. The companies which are using Ray are Amazon, Uber, Lyft, Shopify, Visa, LinkedIn, OpenAI, Microsoft, ByteDance. So this is a very well supported project and a very good project which has run at scale. So go ahead, give it a try, and share your experiences, how it goes with you. Thanks. Have a nice day.